Hello, in this video I want to demonstrate a cellular automata model, and this model starts off with a 100 by 100 grid. So I would like you to imagine a checkerboard or a chessboard where you've got 100 rows and 100 columns. So we've got a 100 by 100 grid, and we're going to initialize this with zeros and ones. And the way we're going to do that is 0 represents calm individuals and 1 represents panicky individuals. And so we're going to randomly put down the zeros and ones, and the way we're going to do that is we've got a probability of 0.1 individuals being in the panicky state. And I'll show you how we'll code that up in a minute. The next thing we're going to do for our models, we're going to use a more neighborhood, and our update rule says that if 4 or more individuals in our neighborhood are panicky, then the individual of interest will become panicky. And this is a model I've adapted from Sayama, who coded this up in Python, and I'm coding it up here in MATLAB. So let's take a look at some of the different features of this cellular automata model. And your goal for your assignment will be to modify this code and to come up with some research questions and ways of qualitatively and quantitatively analyzing this data. Okay, so the first thing we want to do is start off with n equals 100, and that's going to be the size of our grid. Next, I'm going to set p equal to 0.1, and that's the probability of panicky individuals in this initialized grid. Next thing I'm going to do is set up something called random number grid, and this uses a random number generator here in MATLAB. Let's take a look at how that works with a very small little array. So suppose I typed in rand for random number, and I type in a 1 by 3 array. Hit enter, and what MATLAB does is it makes random numbers in an array, 1 row by 3 columns, and these are all random numbers between 0 and 1. Okay? So we've done that up here in our code, but it's much bigger. It's 100 rows in 100 columns. So we're going to make up a bunch of random numbers, put them in 100 rows and columns. And then what I'm going to do is I'm going to use a logical operator here and say, you know, if the numbers in each of those little cells are less than p, less than this 0.01, we're going to make that a 1. We're going to make that a panicky individual. So let me show you how that would work down here in our code, right? So right now I've got my random numbers in an array, and it's called ants or answer. So I'm going to say current grid equals parentheses ants less than 0.1. And what that's going to do is it's going to go through and check each of these values, and if they're less than 0.01, it's going to flip them to a 1, and if it's false, it's going to make it a 0. So that turned my current grid to a 0. All right, let's try this again. And it's not very often I'm going to get low numbers in there, 0.1. All right, so let's just use what we've got here. I'm going to just change the values a little bit. So if I change this to be less than 0.5, for example, we would expect that the only place that's true is in this first cell, so that would flip to a 1. Everybody else would flip to a 0. And indeed, that's how that works. So that's just a quick way in MATLAB of going through the array instead of, checking each individual cell. You can just do it all at once, and that's a nice little logical operator right there. Okay, let's keep going through the code. The other thing I've got here, I've got my current grid, that's all set up, and then I've got a next grid. So that'll be what's going to happen in the future time step. And that's just going to be all zeros. I'm just setting up that data structure so that my code runs faster when I need it. Okay, next thing we're going to do is we're going to build a figure. And so we're just going to make a figure in MATLAB here, and then we're going to use a command called image-esc current grid. So let me copy paste these lines down here to the copy paste these down to the command window, and I'll put in there the 0, 1. Now let's see what image-esc does. Okay, so there's what we've got so far. So you can see that the blue, those are the zeros, and we've got lots of calm individuals, and then we've sprinkled around some panicky individuals denoted here in yellow. All right, so that's our initial setup. All right, now we're going to run the simulation. We're going to do this for time equals 1 through 20, so it's going to be 20 time steps. And we want to go through our grid. Remember, we've got 100 rows and 100 columns, but we want to be really careful with those boundary conditions. We're going to use periodic boundary conditions. And so I'm going to save my analysis for the first row and column and the corners. I'm going to do all that later. So let's just work on the interior of our grid. So I'm going to work on row 2 up through row 99, and then column 2 up through column 99. All right, so let's just start row 2, column 2, for example. And I'm going to be in that cell that's in row 2, column 2, and I'm going to look at the neighbors that are around that cell. And I'm going to count them up. I'm going to count up how many panicky neighbors I have. So panicky neighbors is going to be the sum of a bunch of different cells. And what I really encourage you to do right now is sit down, make a grid, or get out some graph paper, and actually work through these indices, because it'll make a lot more sense. And if you ever need to do this yourself for some application, it's a good exercise to go through to see how these indices work. All right? But this is what this is doing. It's basically counting up the neighbors around our little cell. And if we've got 4 or more, we're going to make that cell of interest, which is our IJ cell, we're going to flip it to a 1, a panic state. Otherwise, it's going to be a 0. All right, so we'll do that, and we'll go through our I and our J indices, and we'll end those up. Now we're going to deal with the boundary conditions, so we're going to hit our first row, and when we're working on the first row, we need to look at the neighbors, and that first row with periodic boundary conditions has a neighbor that's the last row, right, because it wraps around like a torus. So we've gone through and done that. Then we'll do the last row, then we'll do the first column, and then we'll do the last column. And again, if you're a computer science major and you love cellular automata models, you think this is really cool, do go through and work out these indices. It'd be really helpful for you. Last thing we'll go through, and we'll do the 4 corners. So the upper left corner, which is the cell 1-1, the upper right corner, cell 1N, and the bottom left, and then the bottom right. And notice I've left the ends in there, so if I wanted to do like a 1,000 by 1,000 grid or a 5 by 5, the code is flexible, and I wouldn't have to retype everything. I just have to change my N up at the very beginning. All right, so that ends our boundary conditions, and then we're going to dump this next grid into current grid, so that's a synchronous update right there, and then we're going to visualize it, draw now, and run this through for T. So let's see what happens. I'm going to clear everything. To run this code is called panic, so let's do that. Let's panic. And this is really cool. We ran it for 20 time steps, and what ends up happening is we get a bunch of calm individuals. Pretty much everybody calms down, but we do get a few droplets of panicky individuals, and this is called the droplet rule for cellular automata. And you're going to, in your homework assignment, you're going to explore some of the other rules and other modifications you could make for this model.